Okay, for this unit practice test here for number 9, let's look at these numbers. First thing here is some matching. So we have aluminum, beryllium, carbon, and silicon. Okay, which of these has the smallest radius? Which has an electron configuration neon 3s2 3p2? Which has the largest ionization energy? And who has 2 valence electrons? Well, this really means we kind of have to look at the periodic table and see where all these elements are. Okay, these elements, okay, they say here this is aluminum and beryllium and carbon and silicon. Okay, those are the 4 we're talking about, so we can kind of get the look of them. Okay, now let's go back and look at those questions. Which has the smallest atomic radius? Okay, smallest atomic radius is whoever is going to be most up and most right, so that's going to be carbon. So we'll put that one down. So that's C. Okay, which has an electron configuration 3s2, 3p2. 3s2, 3p2, so that's 3s2, that's here. 3p2 was over here, so it's going to be carbon or silicon. Both of those, 3s2. Okay, so these are 1s2, 2s2, 3s2. So 3s2, 3p2 has to be silicon. Okay, so that's silicon, which is answer D. Has the largest ionization energy. Well, the largest ionization energy is going to be the smallest atom, the one that's, there. So that's going to go along back with C. And who has 2 valence electrons? Well, we know beryllium was in column 2, so that's the one that's going to be 2 valence electrons. So we get a lot of that from our periodic table. Okay, multiple choice. How many atomic orbitals are on the 5th energy level when n equals 5? How many atomic orbitals? Okay, so those are like the little circles. And atomic orbitals then on level 5, there's going to be 25 n squared. And if we had to look at that, we'd say there's an S, there's 5p, there's 5d, there's 5 f's. That's 7 of them, 1, 2, 3, 4, 5, 6, 7. And then we're going to have 9. So 1 plus 3 plus 5 plus 7 plus 9, that comes out to be 25. So n squared orbitals. Okay, what's the maximum number of electrons that can fill the 4f orbitals? Any orbit, it doesn't matter, 4f, 5f, 6f, f's always come in 7s. We have to memorize that. Okay, S, P, D, F, 1, 3, 5, 7. So how many electrons can fit in there? Since each one of these can hold 2, then that's going to be 14 electrons. Which of the following is the correct electron configuration for sulfur with a 2- charge? Okay, sulfur with a 2- charge. So let's go back and look at our periodic table. Now we're talking about sulfur. So that's going to be neon. And then we look at this. Here's 3s2 and 3p4. 3s2, 3p4. Okay, I'm going to clear the ink on that page. 3s2, 3p4. Oops. 3s2, 3p4 neon. There it is right there. Answer B. Okay, number 8. Which of the following electron configurations is correct for a ground state neutral atom? So who's following the rules? Who is missing, who's like skipping something? So let's just think about it. 1s2, 2s2, 2p6, 3s2, 3p6 should go 4s, so that's wrong. That's not the answer. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, that sounds great. Let's check the others. 1s2, 2s2, 2p6, 3s2, 3p6, 4s4. There's no way you can have 4 in the s's. And 1s2, 2s2, see, it should have been 2p6. 2p6 is missing there. So that one's not the answer. So it has to be answer B. Which electrons are being placed into orbitals correctly? Okay, so if we were putting things in, then we'd expect to put one of them here, okay, and then 2 like that. And then we would go like here. Okay, so who was following that? C was following that. Okay, that's wrong because we should have gone 1, 1, 1 before we doubled. Here they left out the low ones, and here they should have filled that low one before they started higher. So those all have mistakes. Number 10, consider the element iron. Okay, the electrons in iron that are farthest from the nucleus occupy which orbital? So we have to go back and look at iron. So here's iron over here. So that's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So the last things here are 4s2, Okay, 3d6. Okay, the 4, those are fourth floor electrons. Those are going to be farther from the nucleus than anything else. So the answer to this question was, oops. Okay, so who's the farthest from there is the 4s, the electrons in the 4s. Okay, we haven't gotten to the 4p yet. The electrons in iron that have the highest energy, okay, we saw that was the 4s3d, so those are a little bit higher energy than the 4s's. That's why they fill second. How many orbitals in iron are half filled? That is, have only one electron. Well, let's go back and look here. So everybody up to here, all this stuff here, this has all been filled. Okay, all that's been filled, so that's not okay. It's just these D's, and we have 1, 2, 3, 4, 5, 6 in the D's. So D's come in 5, so we go 1, 2, 3, 4, 5, and 6. So that means we have 1, 2, 3, 4 orbitals here that are unfilled. 4 that are unfilled. Let's go back and check our answers. Okay, how many orbitals are half filled? Okay, 4 of them are half filled because we had our d orbitals. There were 6 in the d orbitals, and it looked like that, so that left us 4 that are half filled. How many valence electrons does iron have? Okay, going back, the 4s, okay, 2, those were our valence electrons because the d's don't count because they were in the level before. So the latest outside ones were the 4s's. Okay, which group of elements form -1 ions? Okay, those are the halogens, if you remember. Okay, the halogens are these guys right here, the ones, right before the noble gases. They're all going to form -1 ions, because if they gain 1 electron, they'll look like a noble gas. Which of the following elements has the same number of valence electrons as carbon? Okay, well, we know everybody in the same family has the same number of valence electrons. So we're looking for silicon, germanium, tin, or lead. Okay, and here's lead. Okay, so that's our answer. So somebody in that same column is carbon. 16. When a neutral chlorine becomes a chloride ion, how and why does it change? Okay, we got chlorine, we got Cl minus. Okay, we have another electron in there, so there's more electron-electron repulsion, so it gets bigger. So we're looking for bigger. Okay, and it's because it has more electron-electron repulsion. So this is the answer. Bigger because it has more electron-electron repulsion. More electrons, therefore more repulsion. Okay, which set of atoms represents the alkali metals? Now we saw this picture on our station review. Okay, and so something we should have learned is that all these guys up here, these peaks, those are all the noble gases. Okay, and that's because for every row, here goes across a row, start over, here's a row, start over, here's a row. So for each row, the very highest ones farthest to the right, those are the noble gases. And so then the very lowest ones in each row, those are the alkali metals. Okay, the alkali metals, because they have the weakest nuclear charge, okay, those are going to be the easiest to remove. That's the lowest ionization energy. So those are the alkali metals. If somebody asked, the Y's would be the alkaline earth metals, and the Z's, I'm not sure. It would have to be somewhere in the middle. Okay, 17 and 18. Consider these elements. Okay, so they're showing you where they are on the periodic table. Who has the largest atomic radius? Okay, largest radius is to the left and down. Okay, so it's tellurium, which has the largest ionization energy. That goes right with the size. So the smallest atom is going to have the bigger ionization energy because it's harder to pull electrons off of something small. So it's Br. Okay, where are the largest atoms located in the periodic table? In the lower left. So remember, we have our periodic table. Okay, then we know that they get bigger to the left, they get bigger down. So the biggest atoms are down here, lower left. Okay, now, cadmium. Okay, write the long form for cadmium. So again, we have this. You could fill that in for yourself. Okay, if that's going to help you, 2s, 3s, 4s, 5s, 6s, 7s. P start with 2, 2p, 3p, 4p, whoops, 4p, 5p, 6p, and 7p. The D's start with 3, so 3D, even though it's between two 4s. 4D, 5D, 6D. And then the F's down here, which fit right in here. Okay, the F's start with 4s, so 4F, 5F. So we can just memorize that if you want. Okay, so where's cadmium? Cadmium is somewhere here in the middle, I believe. There it is. There's cadmium, right below zinc. So that means it would be right here. Okay? So what would cadmium be? It'd be 1s2. Okay? 2s2. I'm going to use a count. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. Okay? And I'm going to clean that up a little bit because I might want to use that picture again. And let's go back to cadmium. So we're going to write that in. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and we got to the 5s2, 4d10. And that's we stopped right down there below zinc. Okay, how many valence electrons? Okay, let's look for valence. Anything, the highest number we have, there they are. Okay, so how many valence electrons? There are 2 valence electrons. Write the short form for the cadmium ion. Okay, 2 things. 2 plus means we're going to lose those valence, so those are going away. And the short form, short form, we go to cadmium and go to here and come back up again. So it's going to be krypton, 5s2, 4d10 would be the neutral. It's going to be krypton, we're losing the 5, so it's just going to be 4d10. Krypton, 4d10. So, okay, krypton, 4d10. We're going to lose those valence electrons. Those are the 2 that leave. That's why it's cadmium 2+. Okay, which is expected to have a larger radius, cadmium or cadmium 2+? Explain briefly. Okay, so we have cadmium has a certain electrons. Cadmium, we had to lose electrons. So the answer is going to be cadmium, neutral, okay, is expected to have a larger radius because it has more electrons and more electron repulsion. And that's the reason that its electron cloud is larger. When you lose electrons, they get smaller, okay, because there's less repulsion. So we say who's larger? The neutral. Okay, consider these 3 elements, K, Ca, and Rb. K, Ca, and Rb. We've got to look at where they are in the periodic table. Here's K, there's Ca, and there's Rb. So they're in a little group like that, K, Rb, and Ca. So I'm going to write that down here for us, K, Rb, Ca. Okay, that's their grouping. Okay, arrange these elements in terms of increasing atomic radius. Increasing atomic radius. So who's the smallest? Upper right is the smallest. So Ca. Okay, bigger than that would be K. Bigger than that would be Rb. Okay, because they get bigger this way and they get bigger this way. So Rb is bigger than K, and K is bigger than Ca, so Ca, K, and Rb. Okay, explain why B has a larger atomic radius than A. Why is K larger than Ca? K larger than Ca. Okay, those 2 are across from each other. So K is larger because it has fewer protons. Okay, fewer protons, and because it's a horizontal, and that's going to mean less attraction. And that's why it gets bigger. Okay, next one here, okay, do these elements in order of increasing ionization energy. Well, ionization energy goes right opposite to size. So for these same ones, I'm just going to do it the other way. So instead of, so K is still going to be in the middle, but Rb will be over here and Ca will be over here. So explain why Y, okay, is higher ionization energy than X. Explain why K has got a greater ionization energy than Rb. So we're talking about a vertical trend here. Okay, why is K? K has fewer layers. Okay, fewer layers. That says layers. I'm going to try to clean that up. Fewer layers. Okay, and that means so the electron that is being removed is closer to the nucleus. And therefore has a stronger attraction. Okay, so the line of reasoning again is that K has fewer layers. Okay, the electron is closer to the nucleus, and therefore it's got a stronger attraction. That's why it has a higher ionization energy. And I believe that that is the end of the test. Okay, and here are the answers at the end, and I think we're good. So that's the practice test.